Let's look at this other control structure called for loop. So just like your while loop, for loop allows you to iterate a set of operations or actions for a number of times. What's good about for loop is that you actually specify the number of times you wish to loop through that set of actions here. So typically, this is what we how we write a for loop, similar to while loop. Instead of using while, you said for, and then there are actually three expressions here. Okay, first one, second one, and third one. And notice that there's a semicolon here, basically ends the expression number one. The second semicolon ends the expression number two. You don't actually need a semicolon for the third one. The very first one is what we call initialization. So this allows you to initialize your variables here, this iteration loop variable or counter. The second part is what we call condition, right, or conditional. So conditional gives you either true or false. As long as the condition is always true, just like inside the while loop, right? That conditional expression, as long as it evaluates to true, your for loop continues. So this is a semicolon here. Third one is what we call increment or decrement, right? Or decrement. So this allows you to either increment or decrement a counter. And as you know, because the counter is always being evaluated inside the conditional, here implicitly, you're allowed for either by incrementing or decrementing that counter, you're inferring the number of iterations you need inside this for loop. So we'll get into a specific example to illustrate this for loop. You can see this high level anatomical differences between a while loop and a for loop. The expressions here inside a while, it's literally the expressions that you have here ending with a semicolon as part of your for loop here, right? This is the second portion of your for loop expressions. And your update at the end, or it could be in the middle, doesn't matter. This update basically updates the number of counts or updating a state, right, of your condition at some point. So whatever this update is in for loop, this update basically updated what we call the counter. So this counter is what's being initialized here. Of course, there's various ways to write this. And as long as your expression continues to evaluate to true, right? Your iteration, right? Your iterations encompassing this compound, right? Actions here will continue. So this while loop is just gonna keep going and going. So there's a loop going on here, there's a loop going on here. Every time you do an update, and then this update result in another state or effect or side effect to be evaluated inside the expression. So this is a high level anatomical differences between a while and a for loop. This program outputs any number starting with 1 to the user specified limit, incrementing by 1 at a time. So if user enters 5, then this program is going to output 1, 2, 3, 4, 5 to the console. If the user enters 3, for example, this program is going to enter, it's going to print out 1, 2, and 3 to the console. So as you can see here, this printf allows the user to enter some number, and this number is going to be stored inside this limit. And this limit, which is an integer, right? This is an integer here, will be a part of your conditional expressions here inside the for loop. So for loop has 3 parts, right? Initialization, condition, right? And then the increment or decrement. So let's look at this. When for loop is executed for the very first time, you do an integer I, okay? So it's important that you declare, right, this I. Sometimes you can take this out. Instead of doing this outside between 13 and 14, somewhere you're going to say integer I, right? Somewhere. And then you can do, in that case, you don't have to declare it as I again, because I now has visibility inside the for loop. I equals 1. Okay, so that starts your loop. And then it's going to check to see, right, if I is less than or equal to limit. So what's the limit? Limit is something that you just entered. So if I is less than or equal to limit, then you're 15. This is line 15. Line 15 is going to be painting, right, with a tab. and a digit and a new line to the console. So whatever this I is, right? Starting with 1. So initially 1 is going to be entered or printed to the console, assuming limit is 3, right? And then the second time around, so I plus plus, right? So I was 1, the very second one, the second time I is going to be 2. So as long as the I is still less than the limit, right, you're going to keep on printing this basically to the console, 1, 2, 3, right? Assuming limit is 3, right? Notice that I less than equal to, right? So the very last one, assuming limit is 3, will still be printed. So this 3 will still be printed to the console. When your loop continues up until the point where I is greater than limit, right? Then the entire loop basically exits, right? So line 16 is going to be evaluated and then program is done because return 0 stops your program. So notice that at each iteration or at end of iteration, I++ is executed. So this very last one, increment, or in your presentation deck, it's called update, happens at the end of the iteration. So as long as this I, right, continuously being evaluated as part of your conditional is less than or equal to limit, your program will continue. So as you can see here in the next page here, if your limit is 3, right, you can see 1, 2, and 3. And by the time you get into the fourth iteration, at the end of the third iteration, I++, right, is going to lead to I equals 4. And of course, that conditional iteration, conditional expression is going to be false. Therefore, nothing. This will actually lead to return, right, 0 at line 16. So you can see here in the prior. So this is a quick example of a for loop being in use. This is another demo. We're demonstrating nested for loop here. Nested for loop means that inside this for loop, there is another one inside of which. So you can have nested, right, for loop. Sometimes you can have 4 nested, 3 nested. Idea is not to have too many nested, but you can see here, whenever you have a 2 nested, it's an indication that you're printing some sort of table, right? So table has both, right, row and also column, right? So it's evident here we're printing some sort of table, and it looks like this is a row. So row is this direction, right? And column is this direction. So at every row, we're printing out the row number starting with 1 up until 3. So what you have here initially, right? This is iteration number 1, right? I equals 1 and I is less than 3. So it's true. And then you move on with your print, which prints row 1. So it looks like there's a semicolon here as well. Now there is a nested for loop here. Nested for loop here uses this other variable. By the way, you cannot use the same variable because this is already declared. You cannot use integer I again. Okay, otherwise you're going to get into a situations. The same variable being declared twice. Can't do that because they're inside the same scope. So use j. J equals 1. As long as j is less than 5, what do? You print, right, this j with 3 spaces. So this is 3 spaces right here. And the number itself, which is j. So you're going to have 1, right, initially. But note that this nested for loop, right, this is nested for loop, is going to keep going, right? Meanwhile, your I is still 1, but this internal iteration is going to go through it 5 times. This is 5 times, right? The first one is 1, right? And then it's going to be 3 spaces over, and then it's going to be 2, right? 3 spaces over is going to be 3, right? 4. And then 5, okay? So ... means there are 3 spaces there. Sometimes, I mean, this 3 is literally 3, but sometimes it could be 5. Depends on how your operating system defines, spaces in general. So this is platform dependent. Now, at the end of your nested, you have this line 15, right? So at the end of your for loop, nested for loop, line 15 prints a new line. So this is going to take the flow of control back, right? All the way to the very next line, okay? Now you're done with the nested. So remember this entire part right here, right? From 1 to 5. This is the nested for loop, okay? And then the outside, this is the outer, okay, for loop, right, in this directions. So nested is in, right, from left to right. Outer for loop is from top to bottom. And the second one is going to be row, right, like here. So I now is going to be 3 because at the end of your line 15, it goes back, right, for I, the outer loop. At the end of the first iteration, I is increment by 1. Okay. Now the very next one is going to be, so I is increment by 1, I becomes 2, right? So instead now you have 2. So same drill. Nested for loop calls for 5 of these, right? 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5 with some spaces in between each digit. And the very last one is, right, /n. So this actually \n. So \n is a new line characters. So this entails that your cursor is going to be at the very next line, printing the very last row, which is row number 3, right? Same drill. You're going to have all the way to 5, last character, right? Takes the cursor onto the very next one. Now let's take a look. At the end of line 15, you're done with the nested for loop. You're about to go back, but I increment again, right? It was 3, now as I plus is gonna give you 4. And of course, if I equals 4, then this is gonna be false, right? Therefore, your entire for loop exits at that point. There's no more to print, okay? So you print 3 rows with 1, 2, 3, 4, 5, right, at each right column. After that, your flow control goes back to 17 when I equals 4. Line 17 returns 0. So your entire program exits at that point. So if you look at the examples here, you see that the end result, right? This is literally a 2-dimensional table here, right, with 3 rows. Row this way, column this way.